Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are starting on another problem on two hinged parabolic arches supported at same level. So let's see the another problem. In this type we will see that one half part will be UDL. Now let's see the when the half part is given, how will you draw the bending moment diagram of the arches. So let's see in details. Now see, this is a question given to us friends. A two hinge, this is nothing but two hinge parabolic arches. It's short form of two hinge parabolic arches. I am writing in exam, there will be full form is there. Okay, a two hinge parabolic arch of span 40 meter and rise 8 meter carries UDL of 25 kilonewton per meter on left half of this span. Find reaction and draw bending moment diagram. This is very important questions. These types of problems comes in the exam on 10 to 12 marks. So let's see how will you get the 10 marks. In the subjects you will getting the step by step marks. So let's start with the step 1, support reaction calculation. Now to find the support reaction calculation, first we have to draw the diagram. So now let's just start drawing the diagram. Now see friend, this is a diagram given to us. A two hinge parabolic arch of span 40 meter, span will be 40 meter, rise will be 8 meter, carries UDL of 25 kilonewton per meter, left half of the UDLs. This is the left half of the UDLs, 25 kilonewton per meter. Now first of all we find the reaction. To find reaction, we know this value will be VA, this value will be VB, and as H is always inward, HB, HA. Okay, now let's start. First of all, what we are doing, first we are taking moment at A. So right over here, taking summation moment at A equal to 0, clockwise positive, always write the sign conventions. So how will it get? See, we are bending moment at A, so this UDL is come in the picture. 25 into 20 into 20 divided by 2. So 25 into 20 into 20 divided by 2. After that minus this VB into 40 is equal to 0. So your value will come off. While solving this, you get the value of VB 125 kilonewton. Now after that, summation Fy equal to 0, upward positive. Okay, upward positive. So when upward is positive, so you can write summation Fy equal to 0. Sorry, I'm writing again. See, now see Va, this is going upward, this value will got is 125 kilonewton. Va minus 20 into 25 into 20 plus 125. Va minus 20 into 25 plus 125 equal to 0. So your Va will come over here is 375 kilonewton. 375 plus 125 will be 500, and 25 into 20 will also 500, means balanced rotor heat. Now in this chapter the main task is to find the horizontal thrust. Now we have not, it's very simple. Second one will be horizontal thrust denoted as H. Apply the formula of as. Now it's quite simple because we will see with previous two sums. Formula will be integration of my dx upon integration of y square dx. This is a formula you will to remember. Now let's start. First we are taking integration of my dx. When we are taking integration of my dx, what you have to see, take a diagram and first take the left part, take a section over here at a distance x, section xx. We have to find bending moment. Let's see, this is x, so this is y. We have to find the bending moment over here. So what are the value will come? See, what 375 into x minus 25 into x by 2 means 25x square by 2. So first of all take the half part. So 0 to 20, 375 into x minus 25x square by 2, because see we are taking section over here, this will go like this, so positive, and this UDL will go like this, so negative. Please remember this is see, this is positive and this is negative, means when this open like this means positive, when it's umbrella like this is negative, means this is positive, this is negative. The section we see section at center, and these are the couples, this is going in positive and this going negative. Okay, sagging and hogging. Now see, this is a sagging part, na, this means plus, this is the hogging part means minus. Sagging, then hogging, positive, negative, simple, and in between is a section. Now after that, y 4h upon l square into lx minus x square. Okay, now we have done this part. After that, sorry, dx, don't forget to write dx plus integration of 0 to 20. Now we are taking at the another part, means this part b and c. Take one section like this distance will be x. Now this is x, this we have to take bending moment over here. So what will value will come? 125 into x, that's it, plus, because 125 means this is going in this direction, means sagging. 4h upon l square into lx minus x square dx. Okay, now after that remove the brackets, take the constant outside. 4h upon l square from both of them, 0 to 20, 375x minus 25. Okay, now you can solve it. So when we are solving this part, you get the value will be 2600 plus this part 1666. Okay, now when solving this, you get the value will be 426.667 into 10 raised to 3. Okay, and this is your nothing but integration of my dx. Now let's move on to y. While solving y, it's very simple. Just what you have to do, just see, integration of y square dx is equal to, formula will be, see, 0 to 40 always take the full length, 4h upon l square into lx minus x square, the whole square dx. Okay, now just put all the values. 4h upon l square take outside, 0 to 40, lx minus x square, the whole square, this is also a whole square, into dx. Okay, so solve this, you get the value will be 1365.333. this is your integration of y square dx. Now put all the values. My dx upon integration of y square dx is equal to 426.667 into 10 raised to 3 upon 1365.333 is equal to 312.5. this is your final h. Now check with check with standard formula. What standard formula says to us? H is equal to WL square upon 16H. So W will be 25. 25 into 40 square divided by 16 into 8 is equal to, this will come 312.5, means your H is equal to 312.5 kilonewton is the final H. Okay, now update it in the diagram only. Okay, now see friends, now we have done with this part. Now in questions we have asked, we have find reaction and draw bending moment diagram. Now let's see, when point load is there, we will directly take bending moment at C, and we have done this diagram. Now in this part, what you have to take, just remember this SA1 lectures. In that, what we are doing, we have to consider different section. First we have to consider AC section, take one section and draw and find the bending maximum positive and maximum negative bending moment to draw the bending moment diagram. Here also we will do these things also. Okay, now see friends, we have done with this two parts. Now third part will be find reaction and draw bending moment diagram. To draw bending moment diagram, let's start with the bending moment calculation. Part 3 will be bending moment calculation. Now follow this sign convention first. Okay, now let's see, first consider part AC. First consider part AC and draw the FBD of the AC part over here, like over here, A and C. This is 375. Okay, now this is the FBD part of this part. This is A and this is C, as we are considering AC first. Now what you have to do, we have to take this section over here, and this distance is nothing but X, and this distance is nothing but Y. Now we have to take the bending moment over here. Now bending moment at X is equal to, now see, this is going in this direction, means this sign conversion, so positive 375 into X. After that UDL will get minus 25x square by 2. 25x square by 2. Now this is also, if you open this arch, this is also hogging, so minus 312.5 into Y. This is nothing but equation number 1. Okay, now just update it. But we know that Y is equal to 4H upon L square into Lx minus X square. So 4 into H will be 8. H will be comes over here 8 upon 40 square into 40x minus X square. Okay, so this will come 1 upon 50 40x minus X square. Put in equation 1. Okay, put in this equation, so we get will be 375 into X minus 25x square by 2 minus 312.5 divided by 50 into 40x minus X square. 40x minus X square. Okay, now solve this one like this. 375x, this will get 12.5x square minus, take it as equation number 2. Okay, now as you all knows, for mx to be maximum, means when we are taking at any section in the arches at one side, to mx to be maximum, d by dx of mx is equal to 0. So right over here is, for mx to be maximum, d by dx of mx is equal to 0. means we have to derivates one time of mx equation and equal to 0. The mx equation will be yours is this one, this equation number 2. So we have to write the derivative of this part. So 375x derivative will be 375, after that minus 12x square means nothing but 25x minus the same as it is constant value upon 50. 40x will be 40 minus x square will be 2x is equal to 0. While solving in the calculator directly, you get the value of x will be 10 meter. Now you get the value of, now put x is equal to 10 meter in equation number 2. We get, now our equation number will be this, we have to put x value over here. So 375 into 10 minus 12.5 into 10 the whole square minus 312.5 divided by 50 into 40 into 10 minus 10 square. Okay, now your bending moment at x will come is 625 kilonewton meter, and this is nothing but yours. Okay, now we have find the maximum positive bending moment is nothing but 62.5 kilonewton per kilonewton meter. Now let's take the other part, consider part C and B. Consider part CV, follow the sign convention, sagging positive, hogging negative. Now let's start. Now draw the FBD of that part or this part also. We know this value will be 125, 312.5, that's it. We have to take one section. We have to take one section and this distance will be x and this is y. We are taking bending moment at here. So at x, at a distance x, so bending moment at x is equal to 125x minus 312.5 into y, equation number 1. We know that y is equal to 4h upon L square into Lx minus x square. So it will come 1 upon 50, 40x minus x square. Put in equation 1. Okay, so equation 1 is this. So 125x minus 312.5 divided by 50, 40x minus x square. Okay, now after that, for mx to be maximum, as you all knows, for mx to be maximum, d by dx of mx equal to 0. Okay, d by dx of mx equal to 0. So we have to put derivate once again. We have to derivate this part. So it will come 125 minus 40 minus 2x is equal to 0. Here x value will come 10 meter. This is named as equation number 2. Put in equation number 2 now. So equation number 2 will be this, 125 into 10 minus 312.5 upon 50, 40 into 10 minus 10 square. Okay, you will get minus 625. So maximum negative bending moment will be 625 kilonewton meter. Okay, now after that we have to draw the diagram. Now our fourth step will be draw bending moment diagram. It's quite simple, friends. Now how will you draw? See, since you are using, as you are seeing a chapter will be arches. So draw the arch first. Draw the arch first like this. And what you have to do is, this is A part, this is B part, and this is your C part. Now see, as positive will be UDL. In UDL, how will you draw the parabola? So we have to draw like this. This is positive and this one is negative. Okay, this is positive and this is negative. 625 kilonewton meter. This is also 625 kilonewton meter, and this one is your L. This is bending moment diagram. Now we have done with these problems. I hope you understand my videos. Share with your friends, and yes, don't forget to subscribe the Ekeeda channel. Thank you.